No, not right now. So, here we are. Everything should be streaming. We should have nice voice from me. We're looking today, if I open up our create timeline, we're looking today to work together to do a 2A and a 2B response. So what is required for 2A and 2B? This is what I want everybody to focus on. I'm going to share out my... Turn that off if you're listening. Can't have double sounds. But somebody did go to the stream and it is working? Okay. It's live for the people that aren't here and the people that won't be here tomorrow. So today we're going to look at 2A and 2B. So right now you should be hearing my voice, seeing the screen, going through here. Somebody keep it running just in case it doesn't work. I'm going to give you view permissions on this document through the classroom. So I'm going to add a document on here. This is period 3. We'll go edit. And if I attach a Google Classroom document, and if I go to recent, it should be this create template 0, exemplar period 3. So where did I get that exemplar document? I'm just giving you can view the file for right now, so that way you can open up and see the document as it grows. But I went to my digital portfolio, and on the digital portfolio, I see a different view of the portfolio than you do. I can go to my period 3, and if I go to the create, overview is going to have the instructions, and then this individual written response and programming code links are going to have templates that I can download. So I have this create written response template in Word. Eventually, I have to save it as a PDF to submit it. Okay? What that means is I just uploaded it to Google Classroom or Google Drive so that you can see this document as it starts to grow. Okay, and then in the end, I'll just save it as a PDF. You don't have to work in Word. In fact, it's probably better if you work on the cloud, just to kind of keep things there. So we know from our reviewing of like what this task is about is make a program that does something. It can be about our own personal interests or whatever. So we have to have a video of the program running. We have to have an individual written response about our development process and our programming code. So let's go through and look at the video. I'm not going to make the video today, but I'll write the 2A response, which is what my video narration will be about. Okay? Clearly label that, and then we'll look at 2B and we'll talk about the development process. Describe the incremental and iterative development process of your program. Focus on 2 distinct points that describe difficulties or opportunities encountered, how they were resolved, difficulties or opportunities were incorporated. You must clearly indicate whether it was a collaborative or independent. At least one of these points should be independent. So, without further ado, here is my wonderful, wonderful app. Anybody remember Android Mash? Android Mash, Android Mole Mash, Whack-A-Mole. Oh. You all created this app, so I'm not spoiling anything for anybody. But let's go and take a look at the overview. So obviously I gave it a theme in honor of Billy Madison because he wanted to see a blue duck because he had never seen a blue duck before. So I made a blue duck and then I just made a background of bubbles. So if we take a look in here, we've got a canvas. On the canvas is an Android sprite. Is that the best name for it? No, it should be called, Duck Sprite or maybe Sprite Duck. Yeah. So we'll rename that. Then I've got. Do I need to rename Canvas 1? No, because it's the only canvas I have. Do I need to rename Horizontal Arrangement 1? No. Label Hits, pretty good. Mm-hmm. Button Reset, pretty good. Label Misses, pretty good. Yep. Label Score is down there. We just can't see it. It's there. Let's go and make the actual canvas percent. Let's make the canvas like 85% and see if that looks better. Let's make the canvas 80% and see if that looks better. This is just for preview purposes, of course, because I want to be able to see everything inside here. So there's our canvas. There's our things. We can see what I'm counting, right? I've got label score. I have a clock. I have a sound. Clock is always enabled 1500 milliseconds at the start. Sound is set to droidsound.mp3, but I'm pretty sure I found a quack sound later on. Notifier, win, and then text to speech. Speech rate 3, pitch 1. So those are my things in here. I'm not using the Android. I'm not using the Android lock. I've got my blue duck. I've got my background, and I've got a background too. Let's go take a look at the blocks, because I've got to guide you through these blocks so you can know what this code is about. Blocks are pretty simple, and I kind of organize this in terms of, here are my variables. I'm counting hits, misses, score, speed, and that's not appropriate. Be quiet. Be quiet, please. Oh, it doesn't like that. I have to do camel case. I don't want to do underscores. I want to be consistent. So be quiet, please. I don't remember what that does, but we'll find out in a second. So there's my variables. The next thing I want to go and find is when screen initialize. Somebody on the live stream, can you confirm you can see the blocks as I'm doing it? Good. Thumbs up. Thank you. So we initialize the screen. We go to move random. All right, let's go find my function move random. All right. So over here, move random, it says call sprite.move to xy. Ooh, and now I've got a little bit of math and logic in here. Move to a random integer, a 1 to the canvas width. However, I don't want my sprite. This is a problem I found. The first problem I found is that the duck would sometimes appear off the canvas. You could only see the edge on it. You could barely hit it. And I solved it by making sure the random integer for the x would be the canvas width minus the width of the duck sprite. So that way, the only way the duck could go there would be all the way on the very edge of the screen. So what does that look like in the designer? The farthest the duck could go would be right here. It can't be over here, which it can if you set the X to something bigger, but then the user can't really play the game easily. So that was one issue I found, and that's the opportunity I took to solve it. So same thing with the Y, minus the duck height. So that way it could only go down this low, and it couldn't get any lower on the canvas because I didn't want it moving off the canvas. That was too challenging, not what I intended for this whack-a-mole game. So we call move random. All right. Now let's take a look at what else we have in here. We've got touched and update values. And I'm pretty sure that's it. And I've got one button reset and clock timer, which calls move random. So reset does something, and we're going to go and look and see. And we're going to see if I can take this one step further, because I think there's one more thing that I can do to add that extra layer of algorithms inside here. So we know how Android Mash works. So canvas touched is the main event we're looking for. We're looking to see where the person touched. Did they touch a sprite? Okay? So because I only have one sprite, I could go and say, if touched any sprite, then we know set touched any sprite to false. So that basically says, all right, we just touched the sprite, and now we're going to say it's false, because we don't want things to happen over and over again. Text to speech gets called, and what does my duck say? Quack. Makes sense, right? Then, okay, somebody's playing on a phone. We call the sound to vibrate for 150 milliseconds to give that haptic feedback so that somebody's pressing. We increment global hits, right? And we say hits equals hits plus 1. And then we set the score to the hits minus half of the misses. Okay? So the way the scoring works in this version of Android Mash is we have every hit you get is 1 point. Every miss you get is minus half a point. So then we call update values, move random, so that way you can't spam the duck in the same spot. That was another problem I ran into. Early on in the code, the duck would stay in the same spot. Somebody could hit it like 5 times and get 5 points really quick. I said, nah, that's too easy. I want to make a change. So that was the second difficulty or the second opportunity I found to make the game more challenging and add an extra enhancement. Then, if the canvas was touched and it wasn't touching any sprite, misses was incremented by 1. And then at the end, the score was updated from the hits minus the misses. And now I'm looking at it and I'm seeing, do I have any duplicate code in this block right here? Where's my duplicate code, Brandon? Yeah, why do I need to do it if we touch a sprite and then again after we touch it? Should I get rid of this? Yeah, that's not the best coding thing. I'm doing the same thing twice. So I'm going to trash it. Did I leave that in there on purpose? I'd like to say yes. No, I'm just noticing it now. Being honest. Okay? So it updates and it calls updates values. Now, same thing here. Do I need to call update values here if I'm going to call it at the end? No, so I'll get rid of update values. Now, I'm intentionally making the decision not to move it to a random location in case they miss. But let's go take a look at what update values does, because that's what we haven't looked at yet, right? So here's update values. So the label score text is joined with score in the global score. The label hits is joined with hits and the global hits. And the label misses is joined with misses and the global misses. Okay. Then I say if the score isn't equal to 0, then we set the score, or then we set global speed to be 1500, which was our timer in milliseconds, minus the score times 50. So we can see here's where I'm using math and logic, because I'm making decisions with my if, then, else, and I'm doing math inside here to slowly decrease the amount of time that the clock timer is going to wait for. So if the score is equal to 0, the clock timer is just going to be reset to 1500. And then the clock timer interval is set to the global speed. This means that if somebody tanks in the game and starts going down a lot in score, the speed's going to adapt and make it a little bit easier. So it won't get to the spot where they can't catch back up again. Okay? Then the last thing I do is I call out and say if global score is greater than or equal to 20, and this global variable be quiet please is equal to 0, call the text-to-speech, that's quacktastic. Now here was another issue I had with the code where it wasn't working the way that I wanted, where once somebody got over 20, every time we hit the duck, it was yelling at us. Every time. So what we added in here was just a little toggle to turn off. So it would only say that's quacktastic after you get to 20. Okay? Button reset resets all of our variables, resets this, and it calls update values. Now, one of the things I kind of don't like right here in this code, notice how I have labels, scores, hits, and misses. I'm updating 3 labels in a row. That's like a giant, hard-to-read block. Let's adapt this code and say this is updating the values. This one right here is really updating the values. Or is values here, or is it better to call it labels? Right? Maybe this is labels. Oh, I want to stick with camel case. So this is update labels. This needs to happen though too, but this one right here is really more of a condition for updating the timer speed, right? The game difficulty. So this would be like adjust game difficulty. adjust difficulty timer. And then this one would, right here, would be like the, winning score. So am I going overboard with procedures here? Yes, because I want to highlight what I'm going to do with it next. So this procedure would be winning score. Okay, so this would call out the winning thing. So now I've got 3 small procedures, and update values was called over here at the end of touching a sprite and at reset. So now it's update labels. But what I want to do is I want to call all 3 of these. So I'm going to make a new procedure that basically updates all. Update all. And I'm going to call the label in here. I'm going to call the adjust timer difficulty. And I'm going to call the winning score. So now all 3 of those things are happening when update all gets called. Now up here, I'm going to say this, I intended this to be update all. Same thing for reset, I intended this to be update all. So there's the game, clock timer is there, it will adjust back and forth. Technically it never ends, is that something I could work on later on? Yeah. But now, can we see in this spot here, where I have a spot that uses user-defined algorithms or precise sets of instructions that contain other sets of instructions that are put together for logic reasons or math reasons or organization reasons. Okay? So now we know how this game works. We know how this code works. Let's go take a look and see what are we supposed to be writing about. Well, provide a written response or audio narration that identifies the programming language, the purpose of your program, and illustrates the video. Can we imagine we're watching the video of it working now and start writing? So now we're over here in the document, and I actually want to put the document side by side if it's not too slow. And it should be this document. So that way I know what I'm doing. So right over here, I'm going to remove this bookmark link because I don't know what it actually is. This is kind of just a text box. Is this going to grow bigger as I start to type in here? Let's take a look and see. Yeah, it's getting bigger. Oh, I don't want to control A in there. I just want to get everything selected in this one. And you know what? I don't even like the way this is treating this piece. I'm going to delete this piece from my template and then insert a single cell table. How can I delete 2A? I'm going to insert a single cell table. Insert table of 1 cell. I just don't like the way that it's carrying over with that, and it's kind of small. So inside here, identify the programming language. This app, I'll give it the name DuckMash, was written in, what am I writing in? MIT App Inventor 2, right? All right. So did I identify the app and what it was written in? All right. What's the purpose of this program? This program or app, I'll say, do they call it an app or do they call it a program? They don't call it. I'll say app. I'll stick with app. This app is basically, I'm not even going to say basically, this back is a game that's designed to simulate the classic whack-a-mole style game with a rubber ducky mole. Okay, what are they going to see inside my app? How can I describe what is there? Remember, they're going to play the game. It moves at random. The speeds automatically adjust to the score. So as the score goes up, it's going to get harder. Score drops, it's going to get easier. And eventually, when it gets to a score of 20, they're going to get a win notification. That's quacktastic. So how can I describe that and saying what's going to happen in the video? What would I say? Imagine the video is there. So in the video, the app starts with the duck sprite moving randomly around the canvas within mathematical and logical bounds. Mathematical and logical boundaries. So see how I'm peppering in what I'm going to talk about for math and logic? Because I only have 150 words to do this. All right. If the user presses and hits the duck, their score goes up, but the timer that calls the duck to move starts to decrease, increasing the difficulty of the game. If the user misses the duck, their score goes down and the timer can increase to reduce difficulty. If the score reaches 20, the app speaks a win message. If the user hits the reset button, everything is set back to starting values. I don't know what my word count is. Anybody remember what the shortcut is for this? Is it Control Shift C? Yeah, highlight it. Control Shift C. 123. Ooh. So can I add a sentence now about the score updates, the misses updates, and then what else was on there on the designer view? Score, hits, and misses update as the user plays. So the labels for score, we'll do it in order. Hits, misses, and score updates as the user plays. Control Shift C. 135 words. Do you feel that adequately answers that we identified the program, the purpose of the program is a game, and we explained what's happening in the video? Now I just need a video that's less than a minute long of somebody getting to the score of 20 so you can hear that's quacktastic. Cool. All right. So next, let's move on to 2B. 200 words. Describe the incremental and iterative development process for your program. Focus on 2 opportunities or difficulties and how we solve them.
What does it mean by opportunity?
Opportunities means maybe you found something that's going to make the app better, or maybe you found somebody wrote a pre-written segment of code that's the exact code and logic you're looking for. Those are opportunities. And how did you incorporate that opportunity into your app?
Do you have one difficulty and one opportunity?
You could have one difficulty and one opportunity, yes. Because if we go into here, response 2B describes or outlines the incremental or iterative process of the entire program, and then it specifies at least 2 points. And it says the response earns the points if it identifies 2 opportunities, 2 difficulties, or one of each. So the exact question you asked is laid out there right in the rubric. Okay? So we're just going back to where the rubric is. All right. So Again, I don't like this text box that's pre-built here, so I'm going to delete it. I'm going to steal this text box and paste it right below, and I'm going to clear out the text that's in there. Clear out the text that's in there, Mr. Wilkosz. Come on. All right, there we go. So now we're ready to write a response for 2b. So 2b is asking, describe the incremental and iterative development process. Okay. So I'm going to talk about how at first I started with following along. Now, for my purposes, I'm going to say that I started with the canvas and I got the duck moving. Once I got the duck moving, I found an issue. The duck could disappear off the edge of the canvas. So I fixed it by adjusting the range where it could be. Then I'm going to say, after the duck was moving and everything was hunky-dory, I started working on the user interface and how we would keep track of the score. So there's my incremental and iterative development process. To start this app, I worked first with designing the canvas and background, canvas, sprite, and background portions of the user interface. I'll say something along the lines of, at first, the duck, the first bit of code written called the duck to move randomly to a x, y coordinate on the canvas. This was where I ran into my first difficulty, in that the duck could randomly appear off the right side of the screen and below the bottom of the screen. Okay? Make sense? To fix this issue, I adjusted the random range for x of the sprite to be the canvas to range from 1 to the canvas width minus the width minus the duck sprite width. This way, the duck couldn't appear beyond the boundaries of the canvas. Beyond the width boundary of the canvas. This process was repeated for the y value and the canvas and sprite height. Let's take a look at my word count right now, see how far I've gone. Because I talked about one opportunity, Control-Shift-C, I'm at 125. So I might have to pull back a little bit in here, like I did repeat some things in here. Maybe rather than saying, process was repeated, I adjusted the range for the x value and y value to range from 1 to canvas width minus the duck width for x, and minus and the